a colossal wave of energized plasma, a massive coronal mass ejection, just erupted from the Sun and is hurtling through space, heading directly for our most baffling cosmic visitor, 3I Atlas. This is not a drill. This is a direct, unpredictable collision between one of the most violent solar events and an object that already defies every single law of physics we thought we understood. NASA, which has spent months desperately trying to minimize the anomalies of this interstellar comet, has been forced to break their silence. They cannot ignore this. It's a sudden, high-stakes threat that instantly turns the study of 3I Atlas from passive observation into a live, unpredictable scientific experiment. Forget the dusty arguments about chemical ratios and weird acceleration for a moment. Right now, we are watching a potential catastrophic impact that could either tear the object apart or, far more interestingly, reveal a core so structurally robust that it confirms our deepest suspicions about its unnatural integrity. The universe just cranked up the pressure, forcing the truth out of this mysterious rogue object. An invisible geomagnetic storm is about to test whether 3I Atlas is merely a fragile ice ball or something much, much harder. The most critical hours of the Atlas flyby are happening right now, demanding immediate answers. The silence is over. The world had settled into NASA's narrative. 3I Atlas is just a comet, albeit an odd one. This calm was carefully constructed, relying on a managed release of data that downplayed the true anomalies. We saw the chemical imbalance, the nickel without the iron, and the straight-line jets, but the official line held steady. Now the Sun has shredded that carefully managed narrative. This incoming coronal mass ejection, or CME, changed everything. NASA's calculated reticence about the object's strange features became instantly untenable the moment the CME was confirmed on its path. The new urgency isn't about discovery, it's about crisis. They are now scrambling to gather data on the object's resilience, which means they must implicitly admit the object is strange enough to warrant this emergency observation. This unexpected solar flare-up means all hands on deck, forcing astronomers to rush new observation requests to ground telescopes and orbital assets like the Hubble and James Webb. The silence they maintained for so long has been shattered by the sheer violence of our own star. The very act of confirming the CME's trajectory toward 3I Atlas is NASA's implicit admission that this is not a standard, easily predictable comet. Why else would they mobilize their entire deep space observation network for a random ice chunk? The true measure of the object is about to be taken in fire and plasma. What exactly is this CME, and why is it so dangerous to a cosmic traveler? A coronal mass ejection is a massive burst of solar wind, magnetic fields, and plasma ejected from the sun's corona at millions of miles per hour. This one is particularly energetic and happened to be aimed perfectly at the path 3I Atlas is currently traversing. When this high-energy plasma hits the object's coma, the thin, fuzzy atmosphere of gas and dust, it creates an enormous, chaotic geomagnetic shockwave. For a typical comet, this impact would be visually dramatic, but often leads to fragmentation and disintegration as the weak structure is stressed. The CME is a chaotic cosmic battering ram, capable of ripping away layers of material and stripping the tail. For 3I Atlas, with its known structural peculiarities, the threat is magnified, but so is the scientific opportunity. This is nature's own extreme pressure test, a forced experiment to see if the object's core can withstand an onslaught far beyond gentle solar heating. The magnetic field embedded in the CME is the key. It's about to slam into the object's own weak magnetic field, and the resulting interaction will be the most revealing observation of its entire flyby. This solar violence gives us the rare chance to measure the object's true density, its rigidity, and its resistance to total disruption. The moment of predicted impact is the most high-stakes cinematic event in space observation right now. Astronomers are bracing themselves for the immediate effects. We anticipate an enormous, sudden brightening of the coma as the plasma violently strips away material, causing a visible shockwave. The key signature will be the disruption of the tail. Comets have two tails, a dust tail and an ion tail, the latter being directly affected by the Sun's magnetic field. The CME is a massive magnetic field anomaly, and when it hits, the ion tail will likely detach completely, an event called a disconnection event. But here is the critical difference. If 3I Atlas is structurally fragile, the nucleus itself will show stress fractures or even major fragmentation. If it's robust, the disconnection event will be clean, and the straight jets will resist the magnetic bending. The plasma will superheat the object's surface, forcing new, deeper layers to instantly sublimate, releasing a flurry of never-before-seen chemical signatures. Imagine a natural object subjected to a particle accelerator, and you start to grasp the scale of this forced interaction. This is not a gentle, passive flyby anymore. It's a cosmic brawl that will reveal the core strength of our interstellar visitor. We need to focus on the stability of the nucleus when the magnetic storm hits. This CME is the ultimate stress test for the object's inherent alien integrity. We already know 3I Atlas possesses that weird, unbalanced chemistry, the nickel without the iron. A traditional comet is a weakly consolidated mix of ice and dust. If that is what 3I Atlas is, the CME impact should cause a chaotic, randomized material loss. If, however, it possesses a denser, more structured core, perhaps the source of the straight jets, it will survive the magnetic shockwave with minimal structural damage. The magnetic fields within the CME will interact differently with metal-rich areas versus icy areas. A metal-rich core would damp the shock and maintain stability. An ice ball would explode. The CME is essentially a probe, forcing us to observe the object's reaction to extreme non-gravitational forces. If the CME impact fails to fragment it, that resilience immediately becomes the strongest evidence yet against the simple comet classification. This is the moment the true nature of 3I Atlas will be physically tested, and the outcome will be binary, total disruption or total confirmation of its exceptional nature. Our telescopes are now looking for a definitive measure of its survival, a test of fire for an object that simply shouldn't be that strong. The CME impact presents an incredible accidental opportunity for bold unexpected chemical revelation. The previous outgassing only allowed us to sample the outermost, most volatile layers of 3I Atlas, which is how we found the strange nickel signature. The high-energy plasma from the CME, however, will strip away that surface layer, digging deeper into the nucleus than any solar heating has managed. This forced sublimation could expose materials hidden beneath the volatile surface ice, allowing us to sample the true bulk composition of this interstellar rock. What if the missing iron is actually buried deep within a dense core? What if the interior contains complex silicates or unknown carbon compounds that our instruments couldn't detect before the impact? This is the core sampling event we couldn't have planned. The sudden, violent shedding of the outer shell acts like a chemical peel, revealing the pristine, never-before-seen ingredients of an alien stellar system. Every molecule released during the shockwave will be a window into the building blocks of another star's planetary formation process. This catastrophic moment is actually the deepest insight we will ever get into the object's fundamental makeup. The most dramatic moment of the entire observation period will be the CME's collision with the forbidden geometry. Those razor-straight jets were previously baffling enough, suggesting an unnatural symmetry or highly ordered ejection mechanism. The key test is whether they can maintain their perfectly straight orientation under the immense chaotic magnetic pressure of the CME. Standard cometary jets would be instantly warped, twisted, and scattered by the magnetic field embedded in the plasma cloud. If the 3I Atlas jets remain straight, if their geometry holds firm, it confirms an unprecedented ejection velocity or a level of structural engineering we cannot explain. This would move the hypothesis needle strongly toward the non-natural, demanding a re-evaluation of every observed feature. Conversely, if the CME successfully scrambles the straight lines into chaos, it might provide a natural explanation for the geometry, perhaps related to a specific magnetic field interaction we had missed. The straightness is the greatest visual anomaly, and the CME is the ultimate magnetic field challenge. We're about to see if nature's chaos can destroy the object's internal order. The threat of the CME has triggered an unprecedented data scramble among the world's greatest astronomical teams. The usual slow bureaucratic process of observation request approvals was thrown out the window. Time is the enemy. Both the James Webb Space Telescope and the Hubble are being aimed at maximum priority to capture the pre- and post-impact data. Ground telescopes, particularly those with high-resolution spectroscopy, have canceled scheduled observations to focus every available lens on the incoming event. This is a scientific mobilization unlike anything seen since the first confirmation of Oumuamua. The key is synchronization, multiple platforms observing the exact same moment of impact from different wavelengths and angles to create a complete three-dimensional picture of the shock. They are not just looking for a flash of light. They are looking for magnetic field interactions, sudden changes in velocity, and the precise moment of tail disconnection. This coordinated action is the scientific community's official, though unstated, acknowledgement that the Atlas object is the most important piece of data in the sky right now. We are the beneficiaries of this emergency, receiving a torrent of synchronized data that might never have been approved under normal circumstances. The entire event forces a powerful evaluation of the Oumuamua comparisonium. Oumuamua's most famous feature was its non-gravitational acceleration with no visible outgassing. The prevailing natural theory suggested that tiny, undetectable jets of hydrogen gas provided the push. Could a sudden, invisible magnetic or plasma interaction, perhaps from a subtle CME, have been responsible for Oumuamua's boost? observing how the CME affects 3I Atlas's acceleration, pushing it, slowing it, or altering its trajectory, will give us critical clues about the forces that govern interstellar objects. If the CME dramatically alters 3I Atlas's speed without obvious massive fragmentation, it gives weight to the idea that non-gravitational boosts can come from subtle magnetic interactions, not just physical outgassing. The test is whether the object's composition makes it unusually susceptible or highly resistant to the sun's magnetic field. This one event will serve as a magnetic blueprint, allowing us to retroactively test the hypotheses that have surrounded Oumuamua for years. The fates of the two greatest interstellar mysteries are about to become linked by a single colossal solar event. This CME impact introduces a fascinating, existential question. Is the object a shield? If 3I Atlas's bizarre internal structure and unique chemistry allow it to survive this extreme solar onslaught, it raises a new and profound possibility. Perhaps its alien design, the suspected robust, metal-rich core, was not built for propulsion, but for protection. In a galaxy filled with erratic stars and violent CMEs, an object with high structural integrity would be essential for long-term survival in the interstellar medium. The ability to resist solar storms could be an evolutionary advantage for any cosmic seed or, dare we say, any sophisticated alien artifact. If the object sails through the plasma cloud relatively unscathed, it tells us that its place of origin builds objects that are far more robust than our own. We would be witnessing an object designed to survive the chaos of space. This test of resilience is the most direct way to probe the object's fundamental purpose. Is it fragile debris, or is it a fortified traveler built to withstand the elements? Its response to the CME defines its cosmic role. The hours since the CME impact have delivered the most electrifying data of the entire mission.